Cars, more than a Pixar favorite, is what we use every day to get to school 5 minutes late. Every time, even if we leave the house 20 minutes early. I always make it 5 minutes late. I need help. Help me. Help.
But what we don't need help on is the physics of tires. You'd think that tires would mean solid physics? No. We are dealing with fluid mechanics. The fluid in our tires? Air. Whoosh. The goal of this project is to find the weight of Julie's dinky Prius and the number of atoms in each tire using the principles of fluid dynamics.
Atom.
And thermodynamics.
Atom.
With a little bit of geometry. One of the integral components of fluid dynamics is pressure, caused by the amount of force the fluid exerts on the walls of its container. Thus, pressure is the force that is supplied to a certain area of an object. To find the number of atoms in each tire, we use the principles of thermodynamics. Notably, we will utilize the ideal gas law, PV equals nRT,
Puff nerd.
which states that pressure and volume are indirectly related, whereas pressure and volume are directly related to temperature and pressure.
Molecule number.
Not pressure. It's not directly related to pressure.
Thus, after using some basic geometry to find the volume of each tire, as well as a thermometer to find the temperature of the environment, we will be able to find the numbers of atoms in each tire. To start off, let's find the weight of Julie's Prius. Once we find this force of the pressure exerted on Julie's poor tires, we can finally calculate the weight of Julie's Prius.
What's up, home dog? Oh, Mr. Johnson. Hello? Is that you, Mr. Johnson? I think my phone's broken. Oh, but hi. How are you doing? Oh, good. Me? Oh, could be better, could be worse. You must be asking for the hypotheses. Well, good thing I've been working on them all day without break or rest. And I've actually formulated some pretty good ones. I hope you're proud, Mr. Johnson. The average Toyota Prius weighs about 2,932 pounds. Taking into consideration the weight of the items in the car, the weight of Julie's Toyota Prius is predicted to be around 3,000 pounds, or obviously around 1,360.78 kilograms. Choo! 1 mole of gas, or 6.022 times 10. Oh, you don't want that hypothesis yet, Mr. Johnson? Oh, okay. Goodbye. Howdy, partner! Navajo Joe out!
This is tire pressure 1. What, 27.9 psi. This is tire pressure 2. It's 31.4 psi. This is tire pressure 3. 32.2 psi. This is tire pressure 4. 31.1 psi.
Go.
14.09 centimeters for tire 1. It's 15 centimeters. still 15 centimeters.
I need a mat. I need a pillow.
Dude, I can't see. Hold on. This is so cool. I can't see now. Help. 14.3 centimeters.
What? That makes no sense. Whatever.
$13.12 centimeters for 15.61 centimeters for tire 3. 15.19 centimeters for tire 3. 13.18 centimeters for tire 4. 13.28 centimeters for tire 4.
To find the weight of the car, we will first have to find the gravitational force on each tire. And we do this by using the pressure equals force over surface area equation, which is part of fluid mechanics. And after we find the force of gravity on each tire of the car, we can add it up to find the total force of gravity of the car. And then all we would have to do is divide the force of gravity by 9.8, and then we'd get the amount of kilograms of the car. Oh, Mr. Johnson. Hello. Oh yeah, I actually got my new phone. I think it's an upgrade. Oh, no, I did not steal any of your candy, Mr. Johnson. Never in my life. Oh, you're asking for another hypothesis? Oh, this one with the number of gas molecules in each tire? Oh, okay. Good thing I just got it done. No, I swear, that's not your candy. Okay, so my hypothesis is 1 mole of gas, or 6.022 times 10 to the 23rd molecules is about 22.4 liters. So each Toyota Prius tire is to be predicted as double that volume. So we're predicting about 1.244 times 10 to the 24th molecules. Yes, you too, Mr. Johnson. Have a could be better, could be worse type of day. Goodbye.
Hi, this is tire 1.
The inner radius is 20.74 centimeters, and the outer radius is 30.42 centimeters.
Oh, I got it. This is what I'm going to do. I'm going to go like this, and then I'm going to measure it with my finger, and then I'm going to pull it out. Okay, let's do that. Okay. That is around 18.3, let's say 2 centimeters for the width. This is tire 2. The inner radius is 20.61 centimeters, and the outer radius is 29.93 centimeters. This is so not accurate. Okay. The width is approximately 18.91 centimeters. Okay, this is tire 3. The inner radius is about 20.62 centimeters. And the outer radius is about it's about 29.85 centimeters. Okay. The width is about 19.32 centimeters. This is tire 4, by the way. The inner radius is 20.72 centimeters. And the outer radius is 29.75 centimeters. Okay. The width is about 19.53 centimeters.
Are you guys doing something for a project?
Yeah.
To find the weight of the car, we will first have to find the gravitational force on each tire. And we do this by using the pressure equals force over surface area equation, which is part of fluid mechanics. And after we find the force of gravity on each tire of the car, we can add it up to find the total force of gravity of the car. And then all we would have to do is divide the force of gravity by 9.8, and then we'd get the amount of kilograms of the car. Now we are going to find the number of air molecules in the tire. We currently know pressure, volume, and we can get temperature from looking at the weather outside. So to find the number of moles in the tire, we'd use PV-nRT. And then once we find the number of moles, N, we then just multiply by Avogadro's constant 6.022 times 10 to the 23rd, and then we get the number of molecules inside the tire.
By using our first understanding of pressure, we were able to find the amount of force exerted on each tire. Our hypothesis was rejected as the percent error was 22.5%. This error could have been accounted for by the presence of other objects in the car, for instance, a full tank of gas. Additionally, we found the atoms in each tire by measuring the inner and outer radii and the width of each tire, then solving for the volume of each tire. Thus, we used the law of thermodynamics with previously found pressures and daily temperature to find the moles of each gas in each tire. There's only one type of gas, though. We found that there was actually more atoms of gas in each tire than what we hypothesized. This could have occurred because we took the pressure measurements during a cold day, which would have made the air more dense. This explains the high number of moles in the tire, despite the volume not quite reaching 44.8 liters, which is double the approximate volume for 1 mole of gas at standard temperature and pressure. Ka-chow!